Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkelberg. Hey, Carl.
Hey, Fred. I was been converting. You know this story, but I converted my business during the pandemic. I converted from on-site consulting to 100% virtual, and both in consulting and teaching. And it made me think of a lot of things, and one of them that I've been musing on recently, because I've been developing some slides about it, is the subject of questioning. And I thought it'd be fun to talk over the subject of questioning as part of our learning, as part of our teaching, as part of interacting between people, just as a general topic.
Well, it's a good topic because I did get a question that was kind of doing exactly that just a couple of days ago. I'm drawing a complete blank on his name. I need to put it in the list. I think I put it in the list to talk to Chris about, because it was about accelerated testing, but it was basically the questioning the assumption that you always have this constant slope or constant shape parameter when you have three different stresses, for example. And I'm like, well, it's not that we assume that, but it was an example of, well, why is that the way it is? And that's a question everything kind of thing. So it gets into the details of what we do and a lot of statistics too. But you're talking about, why am I doing this test in the first place?
Yeah,
it's kind
exactly.
of element.
Yep. And, for example, when I was converting my teaching to being online, I started to question, how do people learn? What is the mechanism of learning? When I went to college back, a few centuries ago, the audiences were very large. You get into a big hall, and there might be 50 or 100 people or more, and there'd be this professor telling you things, and you'd be sitting taking notes,
right? And
you learn a little bit that way, but there's no real dialogue going back and forth, and that's the far end of the spectrum. And of course, another end is one-on-one, where you just have lots of back and forth dialogue. And so I was questioning, what is the mechanism of learning? And it dawned on me after reading a lot about this and the subject of learning, that more learning takes place from questioning than it does just from listening.
Well, not from the lecturer questioning the audience, unless it's done very, very well. I mean, if it turns into what's on the test, then they just learn what's on the test. If the person that is listening is able to ask intelligent questions, then something is working. That's the way I've always phrased it. And you have a practice of, and I've seen you do this, and when we do tutorials and stuff, of prompting questions, like open-ended questions, or how do you relate this to where your situation is, and what questions would come up if you tried to implement this? Those kinds of things are prompting them to ask their own questions. And I think that you see it when it's live, you see the spark come on sometimes. I need to think about this, or what about how this works, or that kind of stuff happens. But yeah.
In my teaching practice, going back to, say, the early 2000s, I would basically present, and then at the end of a slide or a few slides, I'd say, are there any questions? And no hands, continue. Nope. And somewhere around I
learned a cool trick about that just simple phrase, and I experimented with it during a presentation at a conference. There's a whole bunch to it, but one part of it is that if you stand straight, like you're lecturing, right, and your arms are straight or at 90 degrees on your sides, and your good posture, and your voice is, I am telling you this is what we're talking about, you should know this. It's straight across and down, right? This is a command voice kind of thing. And the trick is you move to a different spot than where you were lecturing. You bend one of your knees a little bit, so you relax your posture, and you put your palm up when you gesture to the audience. And instead of saying any questions, which is a yes/no question, by the way. It's, what are your questions?
Yes.
Right?
Yeah, very, very good.
And it worked amazing, because then the next day, same audience, I'm doing another part of my spiel of another part of this presentation, or different presentation. And I stayed in the exact same spot, and I put my hand palm down. What are your questions? Instead of palm up, different spot. What are your questions? Where my voice modulates more like an S wave sound to it. What are your questions? And it was night and day. I would get 10 questions. And then eventually, when I moved to that spot that I was asking questions on the stage, I didn't even get there and I was getting questions. I didn't have to ask.
It's amazing. People want to know.
Yep.
They want to learn, but they don't want to embarrass themselves by asking dumb questions, that kind of thing. There's so much going on in my mind right now. Let me just share a couple of things. I did a transformation, say in about 2006, 2007, where I, instead of just saying, are there any questions? At the end of a period of time, I go around the room and actually look everybody in the eye and say, Mary, what question do you have?
Yeah.
And any questions you have? And she'd think, and oh yeah, I think about this and this, and go around the room that way. And everybody has questions.
Yeah, everybody does. And somewhat you're putting people on the spot, but you've also created an environment where you're going to really try to answer their question or help them, as opposed to, I saw one lecturer lecturing right out of his book. It was photocopied right out of his book, and he was going line by line and basically reading the book loudly to the audience. And somebody asked a question about, how does that connect to the last page? And he looked at him and said, well, if you would read the book and pay attention, you would know.
Dear me.
There were no more questions for the rest of the day.
That's it. And no more learning.
No, it was not safe, right? If you have a pattern of any question that comes up, and especially if you get one early, and you say, that's, instead of saying, oh, that'll come up, or that's on the next, whatever, is address it to some extent, and it is appropriate. And you don't want to get in a rabbit hole or off track, but appropriately. But it's, instead of shutting them down or save those to the end or all these other things, it's basically sending the message, I want you to ask questions. And it's okay. It's safe here to do that. So that when you go around the room like that, you're making space for people that are not as comfortable in a larger group or whatever, but you're also prompting them to say, hey, you need to connect this to what you're doing.
Yeah, and you're creating, like you say here, you're creating an environment where it's safe. And that's so important, because it's vulnerable. To ask a question, a person is vulnerable. That means they have to have humility. They have to understand that they don't already know the topic, and really understanding you don't know the topic is like the entrance point to learning.
Yeah.
And so it's so important. And so there was a transformation where I would go around the room type of thing. Then the last 10 years, I changed entirely. And I actually start my teaching with this preliminary statement that I will be asking you questions. As the instructor, I'm going to be asking you questions, not trying to put you on the spot. And then I talk to them about the whole process of learning. And I basically look for the head nods and the body language that's acceptable to everybody. And it always is, because they do want to learn. And at that point, when I'll teach a principle for maybe a couple of minutes, and then I'll say, Fred, what's that in your own words? Or, Bill, how would you describe this? Or Susan, what if this happens? And I actually literally have a drawing of the classroom, and I just put a check mark next to each name as I ask them questions, so I don't have a bias in some way that's introduced.
Right.
And it creates this dynamic interaction that is a learning environment. So I just wanted to share that story.
Yeah, that's cool. It makes you're setting the expectation right away, and then you follow through, and you have a process for making sure you're asking these questions. Now, do people ask each other questions at some point in that process?
Yes, they do. If they know each other's, particularly if you get a team that is not just a random. In other words, they're part of a project, or they know each other's positions.
Right.
This happens quite often, probably after a half a day or so into the training, is they'll turn to another person. Okay, so we're learning this, Bill. What should we do here?
Yeah. How do we make that work there? Yeah.
It's almost exponential.
Mm-hmm.
And then you have to manage time and you have to stay on topic, but that's all the fun part of teaching.
Well, I think part of it is learning. Now, a completely different thing about question everything is you're running an experiment, and there's this might turn into a rant, but you see somebody set up an experiment and they're trying to show that this is reliable, right? We're running an environmental test and it should work in this temperature, humidity, whatever, right? We often go into some of our tests saying, well, this is what I expect to happen and I should pass. And something goes wrong, right? And something fails, something falls off, something breaks, something corrodes, whatever. And it's just so hard for some people to actually see the problem without just dismissing it or excusing it or throwing out another sample and we got to pass this test. Instead of standing back and going, well, why did that happen? So I think this question, everything is you have to be, again, safe to say, well, why did that happen? What's the failure analysis? How did this occur? Same with field problems. We get a problem, something comes back from the field, and instead of saying, well, we need to fix it, get it back to them, or that was customer abuse, throw it in that pile over there, we can ignore that. It's, why did this happen? Start the 5 whys process right away. And those are questions, but only occur when they're safe to ask.
And yes, indeed, it comes, if I could use the analogy when you say tap into your inner
inner child, yeah.
Yeah, well, it's tap into your inner curiosity.
Yeah.
Because as a child, and hopefully as an adult.
Well, I don't recommend sticking everything in your mouth. That's kind of, at some places that could be very dangerous.
Yes. But hopefully our listeners and the people that are in our field and really all of engineering have a curiosity that drives them.
Yeah.
And you tap into that curiosity to say, well, why did that fail? What the heck is the mechanism that brought that about? Mm-hmm. And you question. And the other thing is, there's so much to this subject, mm-hmm. is don't be afraid of people that have this air of knowledge where that you're afraid to question them, because some people have a over-exaggerated, that's redundant, an exaggerated sense of self.
They have a superlative self-importance. Yeah, I know exactly what you mean. An example of a person that I think epitomied this, very, very knowledgeable, but very approachable. I had the opportunity to sit down for a couple of hours with the guy that invented the technology for inkjet printing. And it was just a lab experiment. If we heat this up, will it come out in a way that we can use, right? If we make a bubble under it, it was kind of just a concept. And they made all these little mock-ups and in the HP labs. And I got to sit down with one of the 5 people that were credited with creating this industry.
Oh, wow.
Right. And I'm trying to learn about the technology, and everybody was saying, oh, you need to talk to this guy. And I said, all right. So I got a couple hours with him, and about halfway through it, he's talking about this and about that, and this didn't work, and we couldn't figure out what to do here, and this, and then there's this issue and that issue and that, and we kind of worked and solved this, and it brought up another one. And at some point I just looked at him and says, it's just like magic. How is it? I mean, today, what we're doing and the quality of the printing that we're doing, which is even better now than it was 20 years ago or 10 years ago, or it was almost 20 years ago that I was there. Do you ever wonder that this was just magic? And he goes, yeah, every time I print a page, I'm just blown away that it works because I know all the ways that it can't work. He goes, I have no idea why it works, as well as it does, because I know there's, and so we had a laugh and then spent the rest of the time talking about the balance of all of these different failure mechanisms. But he had such a genuine curiosity and very willing to share it and going, yeah, we don't know. It kind of works, and we did it twice, and we're like, cool. let's not change it anymore.
You're describing a person has humility.
Oh yeah.
So let's explore this for a minute. As a teacher, mentor, or as just a person, if you're imparting knowledge to somebody, you're telling somebody about something, you can tell them, and they'll listen, and they'll get some of it.
Mm-hmm.
You can also, if you have humility, and I'm not talking about you as the Fred Schenkelberg you, but you as the general world you. If you have humility, you can, as I use this in my teaching about Plato, who was one of Socrates' students. He says that the teacher assumes an ignorant mindset in order to compel the student to a higher level of knowledge.
Mm-hmm.
And what he's saying there is the teacher's basically acting with humility as if he doesn't know something, and turns to the student and asks the student to explain it.
Yep.
And that takes humility, because if you're filled with self-importance, you're going to default to telling the student as opposed to asking the student.
I had the first day of high school physics. There were 6 of us in the class. It wasn't a very big school, and not many of us ever had any idea to go to college. But there were 6 of us in this class, and it was the first hour of the day, the first day of school. And we have a brand new teacher. This young guy comes in, he pulls out his briefcase, and he goes, I don't think I was preparing for this class, and I really don't think it's worth studying. Everything we do, and he put together a logical argument that later we sorted out was a fallacy of some sort in the logic. But it was basically, since everything we measure is arbitrary, we set up arbitrary scales. Why is a foot a foot? Why is a centimeter a centimeter? Those are arbitrary. So everything we know about the physical world is based on these measurements, which are arbitrary. Therefore, everything we know about the world is arbitrary. And therefore, there's no point in learning about this stuff. And he pulled out a paperback and put his feet up. And when you tell me why it's worth learning physics, then we can get started.
Wow.
And he sat there for 3 days.
Seriously?
Yeah. And we were debating and arguing and going through the book and what page is this on? And finally one of my classmates ran into the English teacher that taught logic and laid out the argument that he'd proposed to us. And she said, "Oh, that's a red herring," or, whatever it was, some tautology of a fallacy of logic, and said, well, that's one argument for it. And, it's like, just because this is true doesn't mean these other things are therefore false, or also follow that same pattern. So whatever, we finally called him on that, and he says, okay. Then he was ready to start teaching it, but it took 3 days. Talk about taking a risk that we'd all said, "Oh, cool, free period, let's get out of here." We really wanted to learn this, and he did that over and over and over again. He'd set up an experiment, and instead of telling us if you push this button, the light should come on. So what do you think's going to happen? And then we'd have to set up stuff, and if it didn't work. One of our big experiments was proving that the Earth was flat.
Okay.
We had a pendulum, and we had on the stage in the gym, it had it strung up from the top, and it was a big, shot put ball kind of thing attached to the bottom of it, and we're swinging it. And the problem was that after a while it stopped swinging, so we needed a way to keep it going. And so, we could use electromagnets. We kept it going, and tweaked it and got it so it would swing the right amount got just enough of a kick that it would keep going. And 2 days later, it was still on a dead straight line. And so the headline in our school newspaper is "Physics Class Proves the Earth is Flat," because we were looking for precession, and it didn't do anything. And so later we determined, after spending a lot of time on this thing, we figured out that our electromagnetic field actually corrected its path back to the way the magnet was set up, created a nice little channel that kept it in the same path.
Well, yeah, very good. Well, this is part of the scientific method. The scientific method, if you get to the core of it is about questioning things. You have a hypothesis and then you question it. I'm very concerned about a trend in some educational systems of not questioning.
Yeah.
In other words, a person is not invited to question.
Yeah.
And so I think we have to maintain that as part of the scientific method, is you always want to question. We do it in our podcasts, we do it in our practices, and I think a lot of the reliability field does it, but it should be done throughout engineering, it should be done throughout science, is to keep the questioning. Don't assume anything's correct.
Yep.
Just keep working away at it. And if it is correct, it'll survive the test of time. If it isn't, it'll chip away and you'll get at it. Either way, it's all in the right direction.
Well, it's probably a subject for a whole nother podcast, because it's not just question it for question its sake. It's the curiosity part, I think, is critical here. And when the evidence is there, you got to believe it. And it's credible evidence. It's falsifiable. Yeah. Because there is this concept of, who shot JFK, and it becomes a conspiracy theory.
Oh, yeah, I see where you're going.
So yes. You can ask questions and get yourself into areas where, and the critical test is, can you set up an experiment or make an observation, or can you falsify a statement? And if you're asking a question of, well, there could have been another person there, or, something like that. How many shooters were there? Well, can you falsify that? I did it with my kids. I was saying that North Dakota doesn't exist. It was just a marketing ploy for South Dakota. And, well, have you ever met anybody from North Dakota? We're sitting out here in California and stuff like that. And they'd come up with something and go, well, I just keep moving the goalpost. It was obvious that it was not going to be falsifiable, because I just kept changing the goal. So the questions need to be in the realm of the scientific method. Can I prove to myself one way or the other? And and it's not, to some extent, it's belief, but it's repeatable. Others would follow the same logic. It's falsifiable. And so that's a caution. Don't ask questions just to be annoying.
Oh, totally agree. The concept of the scientific method, it clearly involves questioning, but it also involves experiment. Mm-hmm. It involves verification, and so that's where you get the search for the truth and the validity that you're talking about. It has to be a valid hypothesis, not just a question. So yeah, you don't gain notoriety just by questioning for its own sake. You gain knowledge by questioning and then listening and then experimenting and going back and forth and discussing. Mm-hmm.
Well, that brings up, if you're listening to this, and I suspect there's more than a couple of you out there. So it's been a perennial question for me, Carl, is how many people are actually listening. One way for us to know is for you to ask us a question, if you're listening to this, and let us know what's your experience with this realm of knowledge gaining and learning well. And do you have a story about a favorite instructor or teacher? Maybe you took a class from Carl and still remember the lessons from it. I'm quite sure you would. Send us over your questions. You can do that at accendoreliability.com/go/SOR. And there you can leave us a voice message there's a speak pipe widget there that allows you to leave us a 90-second audio recording, or you could write us a note. You can find Carl and I and the other hosts on LinkedIn or on our About pages. We have plenty of ways for you to join the conversation. So, is this a good spot to wrap up, Carl?
It is. That's a great wrap up, too. Well, great discussion, Fred. Thanks a lot.
All right. Talk to you soon, Carl. Take care.
Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.